Afternoon. Today let me discuss limits with L'Hopital's rule. It is generally pronounced as L'Hopital's rule, right? So this we should discuss, and I will also discuss the greatest integer function and how do we find out the limit of some trigonometric function. See, what is that rule? It is written as like this, but it is pronounced as somebody pronounces L'Hopital's rule and somebody says it as L'Hopital's rule. Whatever it is, you understand the concept. Suppose we have limit x tends to 0, fx upon gx. This is 0 by 0 form or infinity by infinity form. There are many indeterminate forms, but we will apply this rule only in two indeterminate forms, that is 0 by 0 and infinity by infinity. If this kind of a form we get, we can differentiate separately the numerator and denominator unless and until this 0 by 0 form is eliminated. For example, if I talk about basic question, limit x tends to 0, sin x by x, we have studied that this value is always 1. It means that x is 10. When I write like this is equal to 1. It means limiting value of sin x by x is 1. What does it actually mean? It means when x is tending to 0, sin x by x is always tending to 1. It does not mean that this value is exactly 1. This is a value which is near to 1. So I can prove this by this rule also. You can see that this is a 0 by 0 form, right? Because x is tending to 0, sin 0 will be 0, x will be 0, so it is a 0 by 0 form. So what I will do, I will apply this L'Hopital's rule and I will differentiate numerator and denominator separately. So differentiation of this sin x is cos x, differentiation of x is 1. Now cos 0 is 1. When x is tending to 0, it is not exactly 0. So cos 0 is exactly 1. So it is not exactly 1, but yes, the answer would be 1 only. So we have proved that limit x tends to 0, sin x by x is 1. Now what I want to explain is, suppose I apply this thing here and I write it like this. Limit x tends to 0, sin x by x greatest integer function I want to find out. Earlier also I have told you that you might not have seen a question like this equal to 0 because it is meaningless. It is written as limit x tending to 0, means x is not exactly 0, it is tending to 0. Either it is slightly greater than 0 or it is slightly less than 0. So if a student knows that sin x by x is 1 and he writes that greatest integer of this value is 1, it is not necessarily true. Now we need to figure it out what kind of value it will have. Now see, suppose I talk about right hand limit, it will be limit x tends to 0 plus sin x by x. I applied that L'Hopital's rule and it becomes limit x tends to 0 plus cos x. Now come to the quadrant system. This is x equals to 0. At exactly 0, cos 0 is 1. When I am saying 0 plus, so I am moving on this side. X is slightly greater than 0. You know the range of cos x. At this point, it is 1 and then it moves to 0 on 90 degree. So as soon as we move towards 90 degree, the value of cos x decreases from 1 and moves towards 0. So this value is 1 but not exactly 1. It is slightly lesser than 1. So when x is tending to 0 plus cos x is tending to 1 minus. So this is the value which is slightly lesser than 1 but not exactly 1. Similarly, if I talk about left hand limit, it will be limit x tends to 0 minus and same L'Hopital's rule and we will get it here cos x. Now when x is tending to 0 minus, so we will move in fourth quadrant and in fourth quadrant also the value will be positive but it will be slightly less than 1. So this is again 1 minus here, means it is a value less than 1. So we can always say that though we write down like this, limit x tends to 0, sin x by x is 1, but it is not exactly 1, it is a value which is slightly less than 1. Now once we have proved that both right and left hand limit are values slightly less than 1, the answer to this question will be always 0. So this is a very important concept because limit x tends to 0, sin x by x is 1. If you don't understand the concept behind it, if I apply a definite integral here, you will yourself write answer as 1, which is wrong. Because this value is not exactly 1, it is slightly lesser than 1. So its greatest integer will be 0. Now I should move on to one more formula which everybody is very clear about. Limit x tends to 0, 10x by x is also known to everyone. It is also 1. Now again we want to check whether it is slightly greater than 1 or less than 1. So if I talk about left hand limit, limit x tends to 0 minus. This is again the 0 by 0 form. Differentiate numerator and denominator separately. You get sec square x. Now sec 0 is what? 1. Sec 90 degree undefined. So from here to here it moves to plus infinity. From here to here it also moves to plus infinity, right? So as soon as I say x is tending to 0 minus, so here it was 1 at x equals to 0. 0 minus is here, a value lesser than 0. So sec x is moving from 1 to infinity. So here the value will be slightly greater than 1. So if it is greater than 1, although I will say it is 1, but in practicality it is a value slightly greater than 1. And similarly for talk about right hand limit, so it will be limit x tends to 0 plus secant square x. The value will be here. So x tending to 0 plus will be somewhat here. The value will be again greater than 1 because secant x is moving from 1 to infinity in the first quadrant. So this value will be also a value which is greater than 1. So although we say that this is 1, it means that when x is tending to 0, 10x by x is tending to 1. It does not mean that it is exactly 1. It is a value slightly greater than 1. Now if I apply that greatest integer sign here, greatest integer of 10x by x, so answer to this question will be 1 because it is a value greater than 1. Now a very basic question, suppose I write like this, limit x tends to 0, greatest integer of n sin x by x plus greatest integer of n 10x by x where n belongs to a natural number. Now this is a value slightly less than 1. Sin x by x is a value slightly less than 1. So when n is multiplied by a value less than 1, it will become a value less than n. So as soon as it becomes a value less than n, suppose less than 4 it becomes, so greatest integer would be 3. So less than n, so greatest integer would be n minus 1. This is a value slightly greater than 1. So n multiplied by a value slightly greater than 1, this will be a value slightly greater than n. So its greatest integer will be n. So answer to this question will be 2n minus 1. So this was the idea. Idea was, in this short video what we have learned is that in limit we never get the exact value. It is always a neighboring value. It's not this which is a neighboring value. The answer is also a neighboring value. If I say limit x tends to a, fx equals to b, it means that neither x is a nor fx is b. Both are tending values. Here x is tending to a and here fx is tending to b. This is very important. Always limit, whenever we talk of limit, we always talk of the neighboring points, not of that particular point. We are not interested at x equals to a at all. We are only interested at the right of a and left of a. This is what I wanted to explain in this short video. Thank you so much.